microprocessor side. We have what? A, then what? D, then this is now my microprocessor side. So we have A is the width of the address lines, D is the width of the data lines. Then we have some other things, but so now we have the control signals. What are the control signals? Can you help me? Yes. S and read write bar. So now this is now our microprocessor side. Now we have a memory side, and the memory side looks like this. So now this is our memory side. In the memory side, now we have what? Help me. So we can do it like this. So memory side, we have M, then W, and the control signals. Chip select. Chip select OE and write E. Now we will consider case number 4, and now we will generalize it. So now in case number 4, so now we have case number 4. Case number 4 in which A is greater than M, yes? And then D is what? D is greater than W. So in this example, we need multiple rows and multiple. We need, okay, now please remember, if we have case number 4 and I'm giving you a formula, so now if we say, now if we have a general formula, how many chips will be there? Number of chips, help me. So there are two formulas. So the number of chips, there are two formulas. The first formula is the main memory requirement divided by what? Memory available. And if you look at the main memory requirement, so main memory requirement is from microprocessor side. So the main memory requirement from the microprocessor side, so this is now main memory requirement from the microprocessor side. So here, if you look at here from the microprocessor side, so the main memory requirement is 2 to the power A cross D. So you can write it here, it's actually 2 to the power A cross D. Then the main memory available, so the main memory available is now 2 to the power what?
M times by W.
Cross W. So this will go here. So 2 to the power M cross W. Clear? Okay. Now how many? So okay, please remember. Now if you look at here, so these are the number of chips. So since A is greater than M and D is greater than W, so we need multiple rows and multiple columns. Multiple rows and multiple columns. Okay. Now if you look at here column, please remember this was. Now please remember we can say, so we can now divide it into two parts. So this, can you see here? This thing is the number of rows, so we can also write it. The total number of chips is number of rows multiplied by number of what? Columns. And now what is the number of rows? Help me. How many rows will be there? Help me. 2 to the power A divided by 2 to the power M multiplied by, and what will be the number of columns? D divided by W. So these are the number of rows and number of columns. So now can you see here? Now if you look at here, now if we have this thing, so can you see here? So the number of rows, so we can also have some formula. So now what will be the number of rows? So the number of rows required will be actually 2 to the power A divided by 2 to the power M, and if you divide it, so it's actually 2 to the power A minus M. Am I right? Clear? And how many columns will be there? Help me. Number of columns. The number of columns required will be D divided by W. Okay, since remember, we need a decoder if we have multiple rows. If we need a decoder, if we have multiple rows. Okay, please remember, how many rows do we have? 2 to the power A minus M. So what will be the decoder that is required? So the decoder required will be, help me, yes? Anyone can answer? No. Look at the exponent. So the decoder required will be A minus 1, A minus M to the number of rows. How many rows are there? 2 to the power A minus M decoder. Okay, now let's do some example. Because you know, there is now a general. And please remember, if this is very important. Please think of. So now please remember, we studied case number 1. Okay, please remember, if we study case number 1, in case number 1, A was equal to M. Help me. Yes, am I right or not?
Yes.
And D was what?
Equal to W.
Equal to W. If it's not A to M and D was equal to W, so the number of chips will be what? The number of chips will be actually 2 to the power M minus W, A 2 to the power M. So if A is, we can also write it here. So 2 to the power, the total number of chips is actually 2 to the power A divided by 2 to the power M multiplied by D divided by W. Since they are equal, so we can say 2 to the power A divided by 2 to the power A multiplied by D divided by D, and they will cancel out. How many chips will be required? Only 1 chip. Do we need a decoder? No. Okay. Now consider case number 2. This is now my case number 2. What was case number 2? Help me.
A bigger than
A was greater than M.
D equal to W.
D is equal to what? W. Okay. How many rows are there? Please remember the number of rows. 2 to the power A minus M. Okay, and the number of columns is what? D divided by W, and since D is equal to W, so they will cancel out D divided by D, which you required 1 column. Remember the example that we did? And that example, if you remember, okay, in that example, when we did it, so basically A was 14 and M was 12. Remember? So the decoder that we required, so for that example that we did in our last lecture, A was 14 and M was 12. So the decoder that we required was, please remember, so the decoder was, please remember, A minus M multiplied by 2 to the power A minus M, which is actually 14 minus 2 multiplied by 2 to the power 14 minus 2, minus 12, sorry. And then 2 multiplied by 2 to the power 2, which is actually 2 cross 4 decoder, as we did in our last lecture. Any question? Now remember case number 3, and we did it. Please remember. So basically this is a general formula, and if you know this general formula, you can have a special version of one special version. Clear? So case 1, case 2, and case 3 are the special version of the case number 4. Now if you look at here, case number 3. Remember the case number 3. Yes, help me. A is equal to M, and then what? D is greater than W. Okay, so number of rows will be what? So number of rows is equal to 2 to the power A minus M, which is actually 2 to the power A minus A, which is actually 2 to the power 0, which is equal to 1. Please remember, this is all math. This is 7th class and 8th grade math. I'm not going to go into more detail. And the number of columns will be, how many columns will be there? Help me. D divided by W. And please remember, in case number 3, no decoder was required. Why no decoder is required? So can you see the decoder was A minus M multiplied by 2 to the power A minus M, and since A is equal to A, so it is actually A minus A multiplied by 2 to the power A minus A. So this is equal to 0 to 2 to the power 0, 0 to 1 decoder. It doesn't exist. So decoder has at least 2 inputs. Clear? So no decoder is required. Any question? Clear or not clear? So now what I am going to do, I am now going to rub this off and now have a most complicated example in which we have multiple rows and multiple columns. What I am going to do, now I am going to rub everything off. Any question? Okay, so what we are going to do, so now I'm going to do, so this I'm going to rub this off. And I'm going to rub this off. I need to generate an example. Okay, let's assume that we have a memory requirement for a microprocessor is 16 MB. The memory requirement is 16 MB. Let's assume that the address width is, okay, we'll make it data bus width. The data bus width is width on the microprocessor side. Please remember, in the microprocessor side is, so what's given here? D is given here. Let's assume D is equal to 64. Okay, so now if you look at here, so the formula is main memory requirement. So main memory requirement is what? Main memory requirement is, what's the formula? Help me. 2 is for what? No, main memory requirement.
2 to the power of A
2 is for A
time by W.
cross D. So the main memory requirement, okay, in the exam I may give you A, so you have to find D. So there are 3 variables. So memory requirement, which is the memory requirement, then we have 3 variables. So it means 2 will be given and what we need to find 1. Even A and D will be given, so you need to find the memory requirement. Clear? So 2 is for A cross D. So what is 2 is for A cross D? Help me. What's given? So we need to find A. So we need to find A. So 2 is for A cross D, and D is 64. And memory requirement is actually 16 MB, which is equal to 2 is for 4, 2 is for 20, dot 2 is for 3 is equal to 2 is for 8 cross 2 is for 6. And 23, 2 is for 27 is what? 2 is for A cross 2 is for 6, 6 will go down. So basically 2 is for A is equal to 2 is for 27 divided by 2 is for 6. And then 2 is for 21. What is A now? Any question? Okay, now A is 21. Okay. Now this is the main memory requirement. Now we need to find what memory is available. Assume that we have a main memory available. Okay, please remember, now we have a main memory available. So memory available is, let's assume memory available is is for 18 cross 16. What's given here? Tell me. What is M here?
18.
M is 18. What is W here? What is W here? 16. So M is given, the width of the address line on the memory side is given, the width of the data lines on the memory side is given. Okay, now if you look at here, M is 18 and W is 16. Okay, how can we calculate? Okay, now if you look at here, even now here, no, there are multiple formulas here. Okay, so how many number of rows are here? Tell me. Number of rows. 2 is for A minus M. 2 is for A. What is A? 21 minus M, which is 18, which is equal to 2 is for 3, which is equal to, how many rows are required? 8 rows. How many columns? D divided by W. What is D here? 64 divided by 16, 4 rows. How many chips are required? Yes. We have 8 rows, so number of rows multiplied by columns, which is actually 8 multiplied by 4. How many chips are required? 32 chips are required. Any question? Now we required 32 chips. Okay, now again, even if you think of memory available, so think from different. Maybe in the exam I gave you this thing. So okay, now in the exam what I have given you in the form of 2 is for M cross W. Okay, if we think, okay, even if the memory available is, let's assume if we have, now think of another scenario. So let's assume, now we want to calculate the memory available. So let's assume we have the memory available. So now my memory available is what? The memory available is actually 2 to the power 18 cross 16. Clear or not clear? Okay, can I write something like this? Okay, this is 8. I want to convert it in the form of bytes. So how can I write it? So 2 to the power 18 cross 2 cross 8. 2 plus 8 is 16. Can I write something like this? 2 to the power 19. 2 to the power 19 cross 8. Can I write something like this? 2 to the power 9. 2 to the power 10 multiplied by b. So this is actually, what is 2 to the power 9? 5 1 12. What? Kilobyte. Okay, in the exam, maybe if I say, okay, in the exam I may also, okay, the memory available is this. And I may give you, okay, if the memory available is 512 kilobyte, my A is 16, you need to find D. So what will be D? 16. If I give you, okay, the memory available is 512 kilobyte, if the memory available is 512 kilobyte, and W is 16, what will be A? 18. So you can find it. If your two variables are given, you can find the third variable. Any question? Any question? Okay, now, okay, again, if you want to calculate the number of chips here, again, if you want to calculate the number of chips, so the number of chips, I'm now using another formula. So the number of chips will be equal to the main memory requirement divided by main memory available. What is now the memory requirement? In the form of 16 what? 16 MB? What is now my main memory available in kilobyte? 512 KB. Am I right or not? Okay, now can you see B and B will what? Cancel out. So this B and this B will cancel out. So if you look at here, so this is equal to 16M divided by 512 K. And if you look at 16, what is 16? 2 to the power 4. What is M? 2 to the power 20 divided by, what is 512? 2 to the power 9. What is K? 2 to the power 10. So if you look at here, 2 to the power 24 divided by 2 to the power 19. And this is what? Help me. 2 to the power 5. And what is 2 to the power 5? 32 chips, and we have calculated. So you can calculate the total number of chips using different formulas. So you need, okay, so the number of chips is equal to memory requirement by memory available. So here we have used this formula. Or either you can calculate the number of rows and the number of columns. So you can verify your answer from multiple sources, from multiple formula. So that you see that your working is correct. Any question? Any question? Should I proceed? Okay, so what I'm going to do, so I'm going to rub this off, and now I'm going to solve again. So I'm going to solve it from a different perspective. Okay, now I'm going to solve it from a different perspective. What I'm going to do, now what I will do, that I will now draw the main memory map for this. The main memory, how the main memory map will look like. Should I rub this off? Yes or no? Should I rub this off? Okay, now what I'm going to do, so I'm going to rub this off. Okay, so now if you look at here, okay, now the decoder required will be, okay, now just look at the decoder required. What will be the decoder required? The decoder required will be what? A minus M. So how many rows we have? 8 rows. If we have 8 rows, so we have A minus M. So the decoder required will be 21 minus 18 multiplied 2 to the power 21 minus 18 decoder. So this is actually 3 to what? Help me. 3 to 8 decoder will be required. This is clear or not clear? Okay. So what I'm going to do, so now this is, so in this case, so we need a 3 to 8 decoder. So I'm writing it here. So we need a 3 to 8 decoder. We need 8 rows and how many columns? How many columns? 8 rows and how many columns? 4 columns. What I'm going to do, I'm going to rub this off. Now please remember, now we need to draw the main memory map from the microprocessor side. Okay, now if you look at here, what is A now here? A in this example. A is what? How many times will I repeat? What is A? A is now 21. What is D?
64.
It means that now we have the main memory requirement. So this is right, remember, this is now the main memory requirement. So this, can you see here? This is now the main memory requirement. Memory. The size of each data. If you look at here, the size of each data. So the size of each data in the main memory requirement is if you look at here, so it is D, which is actually what? 64. Okay? Now the size of the data in memory is now 64 bits. Okay. How many locations will be there? How many locations will be there here in this example? How many locations are there? I already asked this question in quiz number 1. Yes. How many locations will be there? 2 for
M times by W. Oh, to the power of M.
2 is for A. Because this is the memory requirement, not the memory available. 2 is for A. Because you know we are using 2 is for A cross B. So 2 is for A. There will be 2 is for A locations. If you look at here, 2 is for A location. What is A here? 2 is for 21 location. And can you see here? This is my location number what? This is location number what? Tell me. 0. Then location number 1. And can you calculate 2 is for 21? Can you calculate 2 is for 21? So this will be location number 2 is for 21. Yes, what will be the value? 2097152. 2097151, not 2. Because it will be minus 1. So actually, in general, if I ask this question in the exam, so you can do it like this. 2 is for 21 minus 1. Clear or not clear? Okay. Now each location will have some address. What will be the minimum address in hexadecimal? Okay. Now how many address lines are there? 21. How can we partition this in the terms of 4? 4, 4, 4, 4, 4. 4 multiplied by 5. 20. What is remaining? 1. Okay, so that, okay, 1, 2, 3, 4, 5, 6. We need 6 hexadecimal digits. So if you need 6 hexadecimal digits, so this is actually 0x 0, 0, 3, 4, 5, 6. What will be the next address? Help me. 0, 0, 0, 0, 0, 1 and blah blah blah. Let's assume this as address is, let's assume this address is 592466F. Let's assume this is one address here. What is the next address? 0x what? Yeah, very good. It means that you are now attentive. So let's assume 09247 and what will be the last address? 0x1F. Any question? So now this is what will be the second last address? 0x1F, and this will be actually location number 2097150. Any question? Okay, please remember now. Now we have, this is now the, okay, in the exam I may ask all this question. So this will be the question given. So this is now the main memory map, the logical main memory map from the microprocessor side. So we can call this as the logical map. Okay, so please remember, this is now the logical map from microprocessor side. Now we need to find the physical main memory map. If you look at the physical main memory map, so if you look at now the physical main memory map, so the physical main memory map will look like this. So now the physical main memory map is the blue color. So the physical memory map is, if you look at here, so now we have the physical main memory map. And if you look at the physical memory map, it is actually 2 for m cross w. So 2 for m cross w. If it is 2 for m cross w, what is m here? 2 for 18 cross 16. And if you look at here, so the data size, please remember, what will be the data size here? Help me. Can you tell me? What is the data size here? It's given here. So can you write it here? So the data size is actually w is equal to 16. And if it's, okay, now if you look at here, now the number of locations, the total number of locations here, how many locations will be here? Help me. 2 for m. So we had 2 for 18 locations. Please calculate 2 for 18 for me. Okay, now if you have 2 for 18 locations, so actually, now if you divide this 18 into parts of, so we have 4, 4, 4, 4. 4 multiplied 4, 16, and then we need 2. So how many digits will be required? 1, 2, 3, 4, 5. So what will be the minimum address? 0x what? 1, 2, 3, 4, 5. The next address. Okay, then the last address. 0x what? 3. No, 3. 2 is 1, 1. So because 1, it's 1. 2, 1, 1, which is 3. 3 ones, 1, 1, 1. 7. 1, 1, 1, 1. F. You got it or not got it? So this is all the by this up. So basically the maximum address will be 3, F, 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 F. What will be the second line address? How many what is 2 for 18?
262143.
262143. And this will be location number. This is location 262. Location number 262143. This will be location number 262142. And that address will be 0x3 F F F. Any question? Any question? Okay, now think of the scenario. What I'm going to do now? So now what I'm going to do, please look at here. And now I'm going to, okay. So can we partition? Now what we are going to do? We are going to partition this main memory. Okay, now how many bits are here? 64. How many bits are here? 16. How many columns do we need? 4 columns. We need 4 columns. So what I'm going to do? So I'm going to rub this off. I'm going to rub this up and I'm going to retry. So you can take a screenshot of this because I'm going to rub this up and I'm going to have a logical argument like how can we draw everything in the logical way? So what I'm going to do, now I'm going to rub this off. Done? So can you see here? So now this is my memory requirement, this is my location 0. So now what I'm going to do, so I'm going to rub this off. Okay. What we are going to do, so we can, okay, how many rows are required? How many rows are required? 8 rows. Okay, so can we logically partition this thingy? Okay, I'm not going to draw it again. I'm going to draw it again. And there is a reason for that. I'm going to draw it again. So this main memory map, because I'm going to draw a big stuff. So this can be logically partitioned. So this is now, okay, can you see here, this was D was 64 here. Since we have 8 rows, so we can divide this into 8 rows. Row 0 and what? Row 1, row 2, row 3, row 4. I think I can make the space a little bit. 2, 3, 4, 5, 6, 7 and 8. Clear or not clear? So we can partition this into 6 rows. So can I call this as row 0? Am I right or not? Then row 1, row 2, row 3, row 4, row 5, row 6 and row 7. So we have logically divided this memory into 8 rows because how many rows are there? Please remember now, if you look at here the number of rows, so the number of rows have 8 rows. So if it is 8 rows, so it will go from row 0 to what? Now what we are going to do? Now we have 4 columns. Oh, sorry, that is not done. So we have 4 columns now. We have 4 columns. So we can partition this man memory into 4 columns. 1, 2, 3 and 4. Got it or not got it? So if you look at here, so how many rows are there? 8 rows. How many columns? 4 columns. 8 multiplied by 4? 32. How many chips are there? 32 chips are there. So so now since there are 32 chips, so I can call it this is. So this is my chip number 0, this is my chip number 1, chip number 2, chip number 3, chip number 4, chip 5, chip 6, chip 7, chip 8, chip 9, chip 10, 11, 12, 13, 14, 15, 16, 17, C18, C19, C20, C21, C22, C23, C24, C25, C26, C27, C28, C29, C30 and C51. So it means that we have, and please remember, each physical chips has a size of what? 2 to the power 8 cross 16. So this size is actually, if you look at here, so this is actually 2 to the power 18 cross 16. This is actually 2 to the power 18 cross 16. Am I right or not? Clear or not clear? Okay, now what we are going to do, and this is a very important stuff. This is a very important stuff now. Now if you look at here, and let's remember the important thing is, the most important thing is now. So the most important, so what is the minimum address? And we calculated it 0, 0, 0, 0, 0, 0. And what was the last address here that we calculated it? 0x what? 1 F F F F 1, 2, 3, 4, 5. Clear or not clear? This clear? Okay, now this is a okay. Now we have 8 rows. What will be the next address? Can you tell me? What will be the next address? 0x. The last address. 0x what? No. Because there are 6 digits. And here how many digits are there? 5. So then what should we write here? Got it or not got it? Now we go to if we calculate the next address, what will be the next address?
04.
Yes. So the next address, we add 1 here. And the next address will be 0x 4 0 0 0 0 0 1 2 3 4 5 6. And what will be the last address?
Professor 04.
Huh?
04.
Yeah, 04. What will be the last address?
06.
Huh?
06.
No. 3. We add 3 FFF. So what is 4 plus 3? 7. F F F F. Then what is the next address? Tell me. 08 0 0 0 0. And what will be this address? Tell me. 8. Okay, so we are adding 3. 9 A B 0 B 0 0 0 0. F F F. Yes, I think now you're not doing it intentionally. Good. F F F F F. It means that you are now again. Good. That's good. What is the next address? 0 C 0 0 0 0. What is the next address? C 0 F F F F F. Got it or not got it? Okay. Now, what is the next address? 1 0 0 0 0 1 2 3 4 5, and then it will be 0x 1 what?
1 3 F.
1 3. The same stuff. Now we can, instead of 0, then we can replace that 0 with what? 1. So this is will what? 1 0 0 0 0, and then 0x 1 7 F F F F. And if you go here, so 0x what? 1 8 0 0 0 0 and then 0x what?
1C.
1C F no not B, and then 0x1 C 0 0 0 0 and then we add it. You got it or not got it? Any question? Any question? So now this is actually, now please remember, this is now, this may be the question in exam, this may be the question, and I may give you the same question, maybe it's the same question, but I will change A and M, and this will be one question in exam like this. We will have multiple rows, multiple columns. Okay, so now what I am going to do, I am now going to rub the stuff which is on the right hand side. I am going to rub this stuff.
What happens to the decoder?
Can you give me some time? I didn't design the complete system now. We didn't design the complete system. Because what I'm going to do, have a logical argument. And now we will have a logical argument and I will see that what will happen. What will happen in each case. What I'm going to do, now I'm going to rub this off. And I'm going to draw the whole memory system here. So if you are going to here, so now can you see here? How many rows are there? How many rows? 8 rows. So we have 8 memory chips. So now what we are going to do, so we have 8 memory chips. So what I am going to do, 1, 2, 3, 4. 4 columns. Please remember, we have 4 columns and how many rows? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Please, it's a little bit ugly, but I'm doing it fast. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Please remember, this is my chip 0. This is my what? Chip 1. And this one is? Chip 31. Clear or not clear? Okay, now if you look at the microprocessor side, now please remember, now in the microprocessor side, we have 21 address lines. So if we have 21 address lines, this will be what? Help me. A 20 to what? A00? Yes or no? And now we have data lines 64. This will start from where? D?
63.
63 to D00. Now on the main memory side, if you look at M, what is M here now?
18.
18. What do we call it? M what? M17 to tell what?
00.
M00. And W? W where?
W15.
W15. Then
00.
W00. Okay, now if you look at here, now my M is now 18. So can you see here? Now this is 18 here. So this is A. Please remember, this is A. This is A. This is A. This the red color is A. Please remember, these will be 18 lines. So all of these lines are 18 bits. 18 bits. And all of these 18 lines are connected to what? These are 18 bits. These are connected to the lower order bits. So please remember, so if you look at here, so now we have A20 to A00. So this will be A20. Then A19. And then what? A18. Where it will go? These 3 lines. To the decoder. And with the least significant bits. To my memory. So can you see here? So all of these lines. Now I'm using the green color, and the green color. So we will connect the lower. Okay, please remember, we will connect the lower W bits. And in this example, W is 18. So we will connect the lower. So in general, if it's general, so what I will do it? So I will write it here. A W minus 1. A W minus 1 till what? A00. But since now W is what? W is 18. So what we need to do, so this is general formula in general. So what we can do, we can say A17 to A00 will be connected to all the address lines. So please remember, this is very important. So if you look at here, any chips, so this is actually chip 3, so even this memory chips, if you look at this memory chips, so this chip will be have W17, W16, W15. So W17 will be connected to A17. W16, no, not W, M17. M17, okay, this is my all. So these are all my M. This is M. This is 18 lines, 18 lines, 18 lines, and this is actually M. M is equal to 18. These are all 18 lines. Clear? So A17 will be connected to what? W17. A16 with? Sorry, A17 with M17. A16 with? A16. M blah blah. Any question? Yes?
Isn't W16 is what's A15?
No, W is. No. We are going to connect the address lines, not the data lines. Okay, now please remember. Okay, so address lines are shown in which color? The blue color. Now we have data lines. And the data lines are now doing the black color for it. What is my data lines here? Help me. It is bidirectional. How many bits? Actually, if you look at here, all of this black are W. What is my W here now? 16. Again, we have W. So we connect all these things. So this is actually 16 bits. And I'm not going to connect it, but just they are just like connection. So these are all connected. These are connected. In the exam, you need to connect all the stuff.
Professor?
Yes.
Here it's AM minus 1 or AW minus 1?
What?
The
Yeah. Very good. Very good. It will be A. M minus. Very good. Thank you, Fatma. Got it? Okay. Now each chip will provide how many bits? Each chip will provide how many bits? Each chip will provide W bits. And what is W here now? 16. So if you look at here, so now please remember, now we have 32 bits. So if you look at here, this D64, so can we write something like this? So now we have from D15 to D00 will be provided by this column. Then what? D what? Help me. 31 to 16 will be provided by the second column. D47 to D32 will be provided by the third column, and D63 to D00 will be provided by the last column. D48, yes. Okay. So now with this black line we connected to what? Help me. D what? Help me. D15 to 00. And this black line? D31 to D16. And this black line?
D47.
D32. And this black line? D? Now we have connected all of these chips. What is missing now? What is missing? Decoder. A decoder is missing. So if you look at here, okay, how many rows do we have? 8. So now we need a 3 to 8 decoder. 3 to 8 decoder, which has an enable signal. Where should we connect the enable signal? Huh? Address strobe. We have an address strobe. So the address strobe of the microprocessor now is connected to enable lines. Now we have 3 inputs to the decoder. What do we connect it here to the first line? Tell me. 820. Then what? A19. Then what? How many outputs of decoder we have? 8. Okay, so please, now if you look at here, so now we can see here, so we can say D0, we can also call it decoder 0 or decoder 0, DEC 0. DEC 0 is connected to, this is my row 0, and it is actually connected to chip select here, all the chip select will be enabled in this, chip select here and chip select here. Okay, I can use, I think, another color, I can use the green color. I can use a green color. So this is connected to the chip select of all these things. And where should we have the decoder 1, D1? Where should we connect? The chip select of row 1. This is my row 0. And blah blah blah. And we have DEC 7. Where should I connect it?
Last one.
To the last what? So please remember, this DEC 0, if you cannot draw it, so you can do it like this. So we can see DEC 0, so we can also write something like this. So DEC 0 is connected to chip select of chip 0, chip select of chip 1, chip select of chip 2, and chip select of chip 3. And where should we connect the DEC 1? Help me. Chip select 4, chip select 5, chip select 6, chip select 7, and blah blah blah, and you can do it. And similarly you can okay, now we have, okay, now we didn't connect this, so we have D2, then we have D3, then we have D4, D5, D6. D6 should be connected to what? D6 chip select 24, chip select 25, chip select 26, and chip select 27, and blah blah. So you can fill all the stuff. I'm not going to do that, but you can do it. What's missing now? What is missing now? Read write bar. Okay. So read write bar is connected to what? It is connected to all OE. So it is connected to OE0, OE1, OE2, and blah blah blah. How many OEs are there? 31. OE 31. And the inverse of all of these things is connected to what? WE what? 0, 1, and blah 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 until what? This is clear or not clear? What I'm going to do now? Now I'm going to rub this off, and I'm going to explain another aspect. I'm going to explain another. Please remember, similar question was asked in one of the exams. Similar question, and they were not able. Majority of the students were not able to answer these questions. Clear? Okay. What I'm going to do? So I'm going to rub that thing off, because now I want to have a. So should I rub this off now? So now I'm going to rub this thing off. Now I'm going to rub. The decoders will still be there. The decoder will still. Should I rub this off? Yes? And please remember, this question will be 30% or 33% of your midterm. Now let's assume a scenario. Let's assume a scenario. We have some address. What I'm going to do, let's assume we have some address, and that address okay. Now this address belongs to which row? Can you tell me? Let's say we have this address. This is the address lines, and now these are data lines. What is D here? D is now 64. Remember, D is now 64. If D is 64 here, So let's say we want to access this data A, B, 1, 2, 7, 6, 5, 1. Okay, now what I'm going to do, I'm going to use different colors. Why I'm explaining it. A, B, 1, 2, 6, 2, 5, 7, 9, A, 1, C, and B, 2, 1, 4. If you look at here, all this data is how many bits? What is now the data bit line? 64 bits. Okay, now this address 0x15642 belongs to which row?
5.
It means that this data belongs to row 5. This is somewhere in between. Clear or not clear? So now this belongs to row number 5. Okay, now let's assume microprocessor generate this address 15642C. Okay, now what I'm going to do, so we have this address 15642C. Now we convert this address. Okay, please remember this address is have how many bits? This address is 21 bits. Remember, this is 21 bits. Why it is 21 bits? Because A is 21. When A is 21, if we convert this into binary, so this will be actually C. C is actually 1100. This is actually 0010. 4 is 0100. 6 is 0110. 5 is 0101, and this is 1. Am I right or not? Yes or no? Yeah, this is digital system. I'm just repeating digital system. Now, please remember. Now, if you look at here, what is this thingy? Help me. This is A20. What is this thingy? A19. What is this thingy? 18. So can you see? This is actually 101. So A20 is 1 and it is 0 and 1. If we convert 101 in binary, 101 into binary, what is this thingy? 5. And which row will be enabled? Clear or not clear? Any question? Clear? So now row 5 will be enabled. So it means that now, okay, now please remember it is 101, so it means that D5 will be 1. When D5 is 1, so D5 will be 1. So if D5 is 1, so it means which chip will be enabled? D5. If D5 is 1, which chip will be enabled? C20? C what? 21, C22 and C20? All of these chips will be enabled. How many chips will be enabled at the same time? 4 chips will, and all the remaining chips will be what? Disabled. So these chips, okay, so these chips will be disabled. So now in this example we will be disabled. So only this row enabled, and enabled. So these 4 chips will be, and please remember, for this thing, what will be the value of address row? What will be the value of read-write bar? What will be the value of read-write bar? Anyone? 1 or 0? Depends. It will be 1 if it's a load instruction, and if it's 0, it's store instruction. Or either it will be 1 if you are fetching an instruction, if it is an instruction manually. Think that are all the things, and we covered all this in our previous lectures. Okay, now in this case, okay, now please remember. Now, if you look at here, now okay, how many chips will be enabled? 4. So it means that now we have 4 chips, which is actually C20. Then what? C21. Then we have, okay, what I'm going to do, so I'm going to, I'm going to do it, I do not have enough space. So now I explained it here, so I'm going to rub this off. Okay, so we have 4 chips now. Okay, I'm not showing the disabled chips. So we have C20, then we have C21, then we have C22, then we have C23. And please remember, this C20 and each of these chips, so the lower bits, so can you see here? So this is one. So the lower bits, these bits will go to each main memory. Now 101 is not there. 101 will go to the decoder. What value will go here? Can you see? If you convert this, it will be what? C, 2, 4, 6, and it is 0, 1. So it is 1. Now if you look at here, this, okay, now if you look at the physical memory, so it start, remember, it start from what? It start from 5 bits, it was 5 digits. 0, 0, 0, 0, 0. And what was the last address? 3FFF, remember? Okay, and then this was the same address spaces from here, same address spaces here, and same address spaces here. Okay, now if you look at here, so this, okay, so there will be one location in this C20, and that location will be 0x1642C, and this same location, the first location, it will store what? AB12, AB12. The second chip will store what? The same location. 6 to what? 5, 7. The third chip will store what? 9A1C. And the last chip will store what? D214. And please remember, now the data lines is now 16 bits. So this will go, the data lines, actually remember, this is W15 to W00. So this will be V214, which will be provided to D15 to D00. And then 9A1C. It will be provided where? So D31 to D16, and then 6257. Yes. D47 to D32, and then AB12. D16 to D. So it means that now. So now, okay, now what I'm now going to generalize it. I'm not going to generalize it. Should I have this off now? Okay, so now if microprocessor generates an address, which is the, okay, now this is my logical memory. This is my logical memory or physical memory? This is my logical memory. And if you look at here, my logical memory or physical memory? My physical memory. So we have a logical memory, and now we can map this logical memory map to the physical memory map. Clear? Any question? Should I proceed now? Okay. So now I'm going to rub this off. I'm not going to rub this off. So if we have this case, if we have A is greater than M and D is greater than W, if A is greater than M and D is greater than W, which decoder do we need? So the decoder do we need is what? How many inputs are there? 1, 2, 3. So basically, please remember, so this is actually how many inputs? So we have A minus M inputs. So 1, 2, and last will be N minus M. Then we have chip select 0. Chip select 0. No, row 0. Then row 1. And what will be the last row? To spawn A minus M minus 1. Because when there are 8 rows, we started from 0 to 7. Clear or not clear? Okay, so now generally speaking, we can have, so we have, okay, in each row, please remember, in each row we have how many columns? So okay, how many columns will be there? D divided by W. So now please remember, so now if you look at here, so this will be what? This will be the first chip, this will be the second chip, and blah blah blah. So this will be, okay, please remember, this if you name it from column 1, column 2, and blah blah blah, what will be the last column? Column D divided by W. And if we name it, like instead of having row 0, row 1, it's okay. This is my row 0, okay, just name it, because row 0, then what? Row 1, what will be the last row? To score A minus M minus 1. So we have, again, this column. Okay, each chip. Okay, please remember, now this is very important now. Okay, each chip will provide how many bits? Each chip will provide how many bits? Each chip will provide W bits. So W bits will be provided from here. W. Am I right or not? The second chip. It will also provide how many bits will be provided by this? W. And how many bits will be provided by this? Okay. How many columns do we have? D divided by W. Okay. So if you see, so basically now if you look at here, we have D divided by W. So total number of bits will be what? Total bits. So total bits. Please remember, the total bits will be the number of columns multiplied by the number of bits provided by each column. So number of bits provided by each column. Okay, what is now the number of columns? Tell me, what is now the number of columns? D divided by W. And how many bits are provided by each column? W. If we multiply D divided by W with W will what? Cancel out. And then how many bits will be provided to the microprocessor? D, which is actually D. You got it? Any question? Okay, now if we say that if we have A is greater than M and D is greater than W, so there will be 2 to the power A minus M rows, 2 to the power A minus M. So columns is D divided by W. So the number of rows will be what? 2 to the power clear or not clear? So there will be a total number of chips will be 2 to the power A minus M multiplied by D divided by W. So the total number of chips will be there. Okay, now if there is any